Okay, so question number 5. What is the balanced net ionic equation for this reaction? So first, let's write out this full molecular equation that they gave us in the question. So it's already balanced as well, which is good. We have 2 moles of silver nitrate, aqueous, plus cobalt iodide, aqueous, produces 2 moles of silver iodide, solid, plus cobalt nitrate, aqueous. Okay, so this is the full molecular equation. So when we want to find the balanced net ionic equation, we first need to write down the total ionic equation for this reaction. So when writing out the ionic equation, this just means we separate everything that's in the aqueous phase into their respective ions. So basically, everything in this reaction will be in their ionic form, with the exception of the silver iodide, which is a solid. So if you have a pure solid, liquid, or gas, then it just stays in its same phase, but everything else will be written as the ions. So let's separate silver nitrate into its ions. You get 2 silver silver plus plus 2 nitrate yeah, 2 nitrate, which is NO3 minus. Oh, I'm also going to write in the forms just so that we're consistent. So these are all aqueous. Plus the cobalt iodide. So cobalt has an oxidation state of 2+, and we have 2 singly charged iodines. Okay, so these are all of our reactants, and then I'm just going to continue writing the products down here. So our precipitate stays the same. And then we just separate the cobalt nitrate into its ions. Like so. So this is our full ionic equation. And now when we want to find the net ionic equation, we need to cross out all of the spectator ions. So spectator ions appear the same on both the reactant side and the product side. So if we look at our example, we have 2 nitrate that appears on both sides, and we also have the cobalt ion that appears on both sides as well. So now when we write out our net ionic equation, it's going to be 2 silver plus aqueous plus 2 iodide makes 2 silver iodide solid. Okay, so now let's see what the junior tutor said. Is to consider the following equation. It is a molecular equation for the formation of silver iodide precipitate, and its corresponding ionic equation is the following. So they wrote out all of the ions with the exception of the precipitate. And then from the equation above, it can be observed that the cobalt ion and the nitrate ion appear unchanged on both sides of the equation. This means that when the two solutions are mixed, neither the cobalt ion nor the nitrate ion precipitates in the reaction, hence they can be eliminated. And then they have the net ionic equation as 2 silver plus 2 iodine minus makes 2 silver iodide. The ion that does not participate or does not take part in the chemical reaction is called a spectator ion. From the equation above, the sodium ion and the nitrate ion are both spectator ions, hence they are eliminated in the net ionic equation. The net ionic equation is the chemical equation that shows only those elements, compounds, and ions that are directly involved in the chemical reaction. When writing the net ionic equation, the positively charged silver cation was written first on the reactant side, then followed by the negatively charged chloride ion, anion. Net ionic equations must be balanced by both mass and charge. Balancing by mass means making sure that there are equal numbers of each element. On the other hand, balancing by charge means making sure that the overall charge is the same on both sides of the equation. Yep, so you can see that for our example, we have 2 positively charged silver ions with 2 negatively charged iodine ions. And when you think about the sum of these charges, it's neutral, which is good because on our product side, we just have a neutral compound. So the solution is correct.